Hello student, this is Shiv Mitra going to explain some more questions of mathematical induction. Suppose this is a very good question. Suppose you have a 1.3 plus 2.3 square plus 3.3 cube plus dot plus n dot 3 power n equals to, you need to show 2n minus 1 3 power n plus 1 plus 3 upon 4. You must be very careful in writing your results. Once again, we will see 1.3 plus 2.3 square plus 3.3 cube plus dot plus n dot 3 power n equals to 2n minus 1 3 power n plus 1 plus 3 upon 4. We will follow the same pattern for n equals to 1. For n equals to 1. For n equal to 1, we have 1 dot 3 power 1 in the left hand side, and on the right hand side we will have 2 into 1 minus 1 3 power 1 plus 1 plus 3 upon 4. On simplifying, we will find 3 in the left hand side. On the right hand side, we will find 2 1 is 2 minus 1 2 minus 1 1 1 into 3 power 2 1 into 3 power 2 plus 3 upon 4. This will give the result 3 equals to 3 square means 9, 9 plus 3 12, 12 by 4 equals to 3. So for the LHS we will have the and RHS we will have the same result for n equals to 1. N equals to 1, we have substituted in the n dot 3 power n and 2n minus 1 3 power n plus 1 plus 3 upon 4. How it is done? We have just taken 1 over here, 1 dot 3 power 1 equals to 2 into 1 minus 1 dot 3 power 1 plus 1 plus 3 upon 4 upon 4. On simplifying, left hand side will be 3 only, right hand side will be 2 minus 1 1, and this is 1 3 power 1 plus 1 2 and plus 3 plus 3. Then 3 square 9, 9 into 1 9, 9 plus 3 12, 12 by 4 equal to 3. So left hand side equal to right hand side. Now for n equals to k, before that we will write so the above result, so the result above result is true for n equals to 1. Now for n equal to k, we will just follow the step 1.3 plus 2.3 square plus 3.3 cube plus dot plus k dot 3 power k dot 3 power k equals to 2k minus 1 3 power k plus 1 plus 3 upon 4. Once again we will see 1.3 plus 2.3 square plus 3.3 power 3 plus dot k dot 3 power k. On the place of n we have written k, and this will be 2k minus 1 plus 3 power k plus 1 plus 3 upon 4. So for n equals to k plus 1, 1.3 plus 2.3 square plus 3.3 cube plus dot kth term will be k dot 3 power k plus k plus 1th term will be k plus 1 dot 3 power k plus 1 equals to, on the right hand side we'll replace k with the k plus 1. So replacing k with k plus 1, we will find 2k plus 2, 2k plus 2 minus 1 in the bracket, and here 3 power k plus 1 plus 1 plus 3 upon 4. On simplifying this right hand side portion little bit, we will find 2k plus 2 minus 1 means 1, 2k plus 1 in the bracket, and 3 power k plus 2, k plus 2 plus 3 upon 4. So you will simplify the left hand side portion. Here in the left hand we have 1.3, 2.3 squared, 3.3 cube, and plus k dot 3 power k plus k plus 1 plus 3 dot k plus 1, and the right hand side we have 2k plus 1 dot 3 power k plus 2 plus 3 upon 4. This we have to show for the given left hand side portion. In the given left hand side portion we can see that 1.3 up to kth term, these all terms summation we have in the kth term. These all terms summation we have in the kth term in the right hand side. So this right hand side will be used on the place of this k plus 1 left hand side terms. So replacing that we will find 2k minus 1 3 power k plus 1 plus 3 upon 4 plus k plus 1 term, k plus 1 dot 3 power k plus 1. Very easily you can see that we have written these terms till this term summation. Up to kth term summation we have written in the form of this term, and next term we have written as it is. Now we will simplify these terms to get this result. On simplifying this term, what we can do, we just need to find the LCM first. We will take the LCM, so you will find 2k minus 1 dot 3 power k dot 3 plus 3 plus k plus 1. K plus 1 can be written as, we're taking LCM, 4 times of k plus 1 dot 3 power k dot 3 upon 4. Now on simplification, we have just taken LCM 2k minus 1, 2k minus 1 dot 3 power k plus 1, 3 power k plus 1 is written 3 power k dot 3 plus 3 k plus 1, and taking LCM 4 will be multiplied over here, 4 times of k plus 1 dot 3 power k plus 1 is written 3 power k dot 3. Now you can see that 3 power k dot 3 and 3 power k dot 3 is present in the both the terms. So we can take 3 power k dot 3 as common, because we need to find 3 power k plus 2. So we'll take this 3 power k dot 3, 3 power k dot 3 as common. In the numerator side, 3 power k dot 3 as common. We will find 2k minus 1, 2k minus 1 from this term, and from this term we will find 4 times of k plus 1, means plus 4k and plus 4, and this 3 is alone, so we cannot take common from this 3, so this will be kept like this only, plus 3 upon 4 we have upon 4. So next step is we have 3 power k, and this dot 3 can be written as 3 power k plus 1, and now we can see 2k plus 4k, 6k and minus 1 plus 4 will be written as plus 3 upon 4 plus 3 upon 4. Now this 3 can be taken common from this term. We'll take 3 common, so we'll find 3 power k plus 1 dot 3, and we'll write here 2k plus 1 plus 3 upon 4. Now this 3 can be taken as in the power, and we can have the result 2k plus 1 dot 3 power k plus 2 plus 3 upon 4. So this was the required result which we need to show. This was the required result in the left hand side, right hand side of the k plus 1 term, and the same result we have in the left hand side for k plus 1 term. So we can say that the above result is true for n equals to k plus 1, and so it is true for all the terms. So it is true for true for true for all all the real values. So once again we will see the question. we have this term 1.3, 2.3, and like this. We have followed the same step. For n equals to 1 we have done first. We have shown the result. Then we have taken for n equals to k. We have written the kth term to the left hand side and kth term to the right hand side. Then we have taken k plus 1 term. Now in the k plus 1 term, you must keep in your mind that you have to write the k plus 1th term after kth term. You have to write k plus 1th term after kth term. So you've written k plus 1th term after kth term, and this is the left hand side portion and this is the right hand side portion for k plus 1th term. On simplifying this right hand side portion of the k plus 1th term, you are getting this result, and for the left hand side portion, the same result we have in the kth term till this term. So this will be used, or this will get replaced with this term that we have done. And next, after on simplification, we need to, from this and this combinedly, we have to show this result. So we have taken on simplification, we have taken LCM, then taken some common, and on simplifying we got the result similar to k plus 1th term right hand side portion. So now we can say that the above result is true for n equals to k plus 1. The above result is true for all real values. Till that, thank you. We will see some more questions of mathematical induction in the next lecture. Thank you.